We usually imagine the internet as a straight line. You type in a URL, and an uninterrupted connection links your device directly to a website server. But this direct path creates a security risk. In a straight-line connection, the target server immediately sees your IP address, which reveals your digital identity and your physical location. The server is equally at risk. By allowing a direct connection, the server's own IP address is exposed to the public, making it a visible target for malicious attacks or sudden spikes in traffic that can take it offline. To prevent these vulnerabilities, system designers use a concept called decoupling. Instead of a direct wire, the two parties communicate through a middleman, ensuring they never actually connect to one another. This intermediary component is known as a proxy. Maintaining a secure network requires replacing these direct links with architectural middlemen. This adds a layer of separation between the user and the server that protects the identity and stability of both sides. The first variation is the forward proxy. This is a server that sits in front of a group of clients, intercepting every request they send out to the internet. You can think of it like a personal shopper. Instead of going to the store yourself, you give the shopper your list. The store only ever interacts with the shopper, while you remain at home, completely unknown to the merchant. In technical terms, the proxy intercepts your request and strips away your IP address. It replaces it with its own IP before fetching the data from the web, ensuring the destination server never knows who the original requester was. Because the proxy sits between the user and the web, it can also act as a filter. An organization can program it to block access to specific types of content or known malicious websites before a user ever reaches them. Ultimately, the forward proxy advocates for the client, ensuring that no server on the internet ever communicates directly with a specific user's machine. If we look at the opposite side of the connection, we find a symmetrical counterpart, the reverse proxy. While the forward proxy shields the user, the reverse proxy is designed to protect the server. This is like a corporate receptionist. A visitor can't just walk into the CEO's office. They must speak to the receptionist, who then retrieves the information or documents from the backrooms on the visitor's behalf. This process is managed through DNS. When you type a URL, the system is configured so that the query returns the IP address of the reverse proxy, purposefully hiding the true location of the origin servers from the public. This creates a perfect architectural balance. The reverse proxy ensures that no outside client ever communicates directly with the internal origin server. Beyond identity protection, the reverse proxy serves as the primary mechanism for managing the high-volume traffic of the modern web. When a website receives thousands of hits at once, a single server can easily crash under the pressure. To prevent this, the reverse proxy acts as a load balancer, sorting incoming requests and distributing them evenly across a group of hidden backend servers. The proxy also speeds up delivery by caching frequently requested files, like a popular image or video. It stores a temporary copy of that file right at the network boundary. When the next user asks for that same file, the proxy sends its local copy immediately. This prevents the request from ever reaching the origin server, which reduces the server's workload and gets the content to the user much faster. This layer also handles the heavy lifting of security. Every secure interaction uses SSL encryption, which requires the server to perform complex mathematical calculations for every request and response. By offloading this decryption and encryption to the reverse proxy, the origin servers can focus their processing power entirely on the application's core logic. These invisible layers of infrastructure are what make the speed, resilience, and scale of the modern web physically possible. Of course, these benefits come with architectural trade-offs. Routing all traffic through a proxy increases the complexity of the system and introduces a slight delay as each request undergoes extra processing steps. There is also the risk of a total system failure. If the reverse proxy goes down, the path to the servers is cut off entirely. To avoid this, engineers must design redundant systems and failover mechanisms to protect the proxy itself. The direct connection we seem to experience when browsing the web is actually a result of complex back-end engineering. The speed and security of the modern web depend on these symmetrical proxy layers, which isolate clients and servers to keep both parties secure.